Good morning, everyone. I'm Mirko Marras from University of Cagliari, and I'm going to chair this session. I see that we have all the presenter except Juliana Marin. If she's here, please put her name in the platform, please. We are going to start in 2 minutes.
E super acum, ieri, parcă.
YouTube. Costi, vrei să spui ceva?
Da.
Mi s-a părut că ai ridicat mâna. Ok. Am mai clarificat câteva aspecte administrative, da? Ok. Hai să vedem cine vrea să mai facă exercițiul.
Pe cine a mai rămas?
You should go for setting a name. You should go on settings and then put your name in the profiles file tab.
Bun, eu am ales cariera și ca intenție și ce rezultat vreau să obțin, intenția este de a-mi schimba cariera și de a deveni consilier de dezvoltare personală și după facultatea de psihologie psiholog, de a lucra cu oamenii și de a ajuta să se transforme. Ca și rezultat personal vreau să obțin împlinire, pasiune, echilibru, libertate și învățare continuă și de asemenea, evident, și remunerație. Mă motivează dorința de contribuție și pasiunea pentru dezvoltare personală, pentru că
Sorry, okay, so we can start. Please, I ask to everyone to unmute. You can mute Juliana, please. Okay, great. Okay, so thanks for being here. Good afternoon. We are going to start this very interesting session of ICCSA 2020. We have 4 very interesting presentation, and we are going to start with Edwin Rojas. Please, so I remember to all the speakers that you have 8 minutes for your presentation, and you should go on you are going to share your screen and then start. Okay.
Okay.
So Edwin Rojas from Federal University of Para. He's going to present the paper entitled One Class SVM to Identify Candidates to Reference Genes Based on the Augment of RNA Sequences Data with Generative Adversarial Networks. Edwin, I would like to ask you to start sharing your screen, and please feel free to start when you are ready.
Okay. Hello, good afternoon. Can you see my screen?
Yes, perfect. Please start. Okay, great.
Okay, hello everyone. My name is Edwin, and I am a student from Federal University of Pará in Brazil. I am here to present one class SVN to identify candidates to reference genes based on the augment of RNA sequence data with generative adversarial networks. This work was developed by me and my colleagues. Here is the summary of the presentation. First, I will give you an introduction of the reference genes and the identification of these genes. Second, I will talk about our proposed method, and then I will show the experiment and results. Finally, I will talk about the conclusion and future works. So, the reference genes are constituted genes necessary for the maintenance of the basic cellular functions. These genes are used in internal control and investigation of the gene expression analysis because their level of expression remains almost constant under normal or abnormal conditions. For example, in real-time PCR, the reference genes are used to normalize the gene expression obtained, since this expression may vary due to the imperfection of the technology used. Actually, there are different methods to identify candidates for reference genes. The picture shows the general pipeline where from a strategy and an RNA sequence dataset which contains some real reference genes and unclassified genes, new candidates for reference genes can be identified. So, The principal disadvantage of current strategies is the small number of reference genes available for tissues or cells, and generally the current methods use the Euclidean distance as a metric of similarity between genes, which we consider inappropriate because there may be genes that have a high value for this metric, but their level of expression remains stable. For this, we can propose a noise approach to identify candidates for reference genes. This approach consists in two main steps. First, the GAN is used to increase the set of reference genes. This allows increasing the diversity of this data. And second, an A1 class SVM based on novelty detection is trained using some real reference genes and synthetic genes generated by the GAN architecture in the first step. So finally, remember that there is an initial step. In this step, we process the data. So this is the pipeline from the data processing. First, we normalize the data by RPKM and applying the logarithm of base 2 plus 1 to mitigate the number of outliers and increasing the proximity of these data features. Later, we remove the genes that present a coefficient of variation outside their interquartile range. And finally, the data was scaled between -1 and 1 because we implemented hyperbolic tangent activation in the GAN architecture. So the picture shows the GAN architecture training. This process occurs in two steps. First, the discriminator network is trained based on the reference genes and synthetic genes generated by the GAN network. And second, the generator network is trained based on an input noise vector to maximize the probability that the discriminator network makes a mistake. Finally, after repeating step 1 and 2 for a defined number of epochs, the generator network will be able to generate synthetic genes similar to the reference genes. So this is the proposed architecture where the generator and discriminator network are fully connected networks, and the generator network receives as input a noise vector based on a Gaussian distribution. And finally, the networks are trained with stochastic gradient descent. So to evaluate the performance of the GAN architecture, we use a similar. So to evaluate the performance of the GAN architecture, we use a similarity metric between synthetic and real genes. This metric uses the absolute distance between real reference genes and synthetic genes, and also consider the precision of the discriminator network. We also propose an e-metric to select the best set of synthetic genes. And finally, we employ other metrics such as binary cross entropy and precision score to evaluate the performance of the GAN architecture. For the one-class SVN, we train it with a Gaussian kernel and evaluate its performance using the recall score. Since we only have the positive class, the class of reference genes. So now I am going to talk about the experiments and results. The proposed method was evaluated with Escherichia coli datasets. The table shows the parameters used to train the GAN architecture, and the picture shows the convergence process. From this convergence process, we can see that the GAN architecture converges close to 0.7, indicating that the generator network is generating genes similar to the real genes. Is generating synthetic genes similar to the real genes. Also, the precision score of the discriminator networks converges close to 0.5, indicating that the discriminator network fails to distinguish between real and synthetic genes. So the picture showed a 2-PCA representation of the real reference genes and the synthetic genes generated by the GAN architecture. Here, we can see that the genes generated by the GAN architecture are not distant from the real reference genes. Now, for the selection of the candidate genes, we train the one-class classifier with 70% of reference genes and the set of synthetic genes. The picture on the right shows the two PCR representation of the reference genes and the candidate genes selected by the proposed classifier. And the table shows the recall score obtained in the training and test data. Finally, we selected 11 candidate genes that coincided with another study. Now, to comparing that increasing the set of reference genes using the GAN architecture improve the performance of the classifier, we trained the proposed classifier based only on the unaugmented data and compared with the training classifier with augmented data. The table shows that with increasing data set here, we improved the recall score for the proposed method by 19%. As conclusion, we can conclude that increasing the reference genes set improved the performance of the proposed classifier. Furthermore, we can conclude that implementing GAN neighbors and one-class classifier is a suitable solution to solve the problem of identifying reference genes. And for future works, we can implement other GAN architectures, and we can also do a better adjustment of hyperparameters, and we can also test other one-class classifier. For example, a one-class classifier based on generative adversarial neighbors. Finally, thank you for your attention.
Great. Thanks, Edwin, for your presentation and also for the fact that you stayed perfectly on time. First, I would like to ask if anyone in the audience has any question for Edwin. Please raise your hand, and I can give you the word. Okay, I see that nobody raised their hand. So, Edwin, I have, just out of curiosity, have you planned to assess how your procedure is generalizable to other bacteria and infections beyond the Escherichia coli, based on other data sets and other kind of bacteria and infections?
Yes, I really.
Do you think that this is a problem of finding good data sets for your purpose, or it's just a matter of doing more experiments on this?
Yes, the problem is that we done many data sets for this experiment, but now I trying with more data sets.
Okay, great. Okay, thanks again, Edwin, for your presentation, and let's move on to the second presenter, Weronika Westwanska from ING Bank Zlasky SA. She's going to present a paper entitled Machine Learning in Object Recognition and Segmentation by Certain Class Neural Networks. Veronica, please feel free to share your screen and start when you are ready. Okay, Veronica, I can see your screen, but I can't hear you.
Veronica, unmute the microphone, please.
Veronica, please unmute your microphone, and we are ready to start.
Sorry.
Okay, great. Now perfect. I can hear you perfectly. Okay, please feel free to start.
Okay, can you see my presentation?
Yeah, maybe you can put the presentation as a full screen. Okay, perfect.
Okay,
feel free to start.
All right. Hello, everyone. My name is Weronika Westwanska, and I come from Poland. I work as a data scientist in a bank. And today I would like to present Jerzy Spontek from Silesian University of Technology and my work on machine learning in object segmentation by certain class neural network. It is a continuation of our previous work, which was focused on fast segmentation, efficient dataset preparation, and counting instances of objects. Here is a plan of my presentation. First, I'd like to give you some basic information to introduce what is the paper about. And as the binarization process is the one we focused on, there will be an explanation of the main concept of our algorithm. Next, I'd like to present to you a description of experiments we did on the neural network we had built and results we gained. In the end, a few words about our plans for the future. So our work is a novel approach to object segmentation using convolutional neural network with a specific architecture called UNet. A majority of research in this area assumes that an object segmentation, an object location is provided by a rectangle tightly encompassing its border. So we propose to use a circle with its center placed on the object. We achieved fast and memory efficient segmentation process, simplified object representation in training of neural network, and gained accurate results in meaning of counting instances of an object and segmentation process. Let's have a look at the simplified schema of dataset preparation process. Each object, in our case it's a honeybee, is marked with a point. Each point location for each bee is saved in a database file, and this way we get data to train and test the network. It makes the data preparation process significantly shorter because we do not need to manually segment each picture and in each object in each picture. While training process runs, a circle is being drawn with its center on the location given in database file, and a linear probability decrease function is implemented with a minimum probability declared for the edge of the circle and maximum probability for the center of the circle. Any pixels lying outside of the circle are considered to belong fully to the background. To get segmentation improved, we decided to split segmentation process in two parts, coarse and accurate, with configurable parameters BTC and BTA respectively. Details of the algorithm can be studied on our website on GitHub, which you can see on the screen. And well, in the first step, we perform windowed segmentation with image divided into equal parts of square dimensions, which are configurable parameters. A binarization process was then performed to get general positions of object. A parameter called BTC decided on how each pixel was finally classified, object or background. The results of the coarse segmentation step were white blobs on black background, and they were representing coarse locations of objects, which were then used in the next step. The next step, called accurate segmentation, is slightly more complex, and it is focused on dividing the whole segmented picture from previous step into squares of dimensions of 100 by 100 pixels. This also can be changed within the code. Having such a collection of squares, the algorithm looks into separate collections of adjacent squares with white blobs. Such separate collections are considered as regions of interest, and instead of concentrating on the whole image, a detailed segmentation analyzes only selected rectangular fragments of the image. A binarization process runs again, and this time with a different parameter named as BTA. In our experiment, we used a set of 71 images of bees. We get those images from database, which you can see on the screen. During selection process, we focused on two main aspects. We decided that at least 4 objects should be in the picture, and objects should be placed in possibly different locations in the image. We trained 9 neural networks using algorithm described in our previous work. We of course modified it in terms of segmentation process and examined the impact of chosen parameter on segmentation results. During experiments, we were analyzing the influence of BTC parameter on the heat map creation process. We also discovered that minimum B probability, B radius, and BTA have a huge impact on the results. And the methods we used to analyze the results were computing IOU, so the Jacquard index, and also object and background classification error. OOI stands for an object and NOOI stands for the background. The first method was to compute Jacquard index for each pair of binary images as well as for the whole set of images. It is also called intersection over union, as its result is a quotient of intersection of two sets of data over the union. So the higher IOU is, the better performance of the network. Our datasets were white pixels location in automatically and manually segmented images, and the results are presented in the table, and you can also see a graphical interpretation of Jacquard index results. Each line refers to a different B radius setting. It is obvious that Jacquard index strongly depends on BTA, B radius, and minimum B probability parameters, and the best performance of IOU is 64.57. The other way to compare achieved results with manually segmented objects was to find how many pixels were not assigned to object during automatic segmentation, while they should be, and consequently we looked for those pixels which were incorrectly classified as an object. We analyzed the behavior of object and background classification error values in terms of changes made to BTA parameter. In the figure, increasing function represents background pixel classification error, while decreasing line refers to object pixel classification error. As you can see in the plot, there is a cross point, which is interpreted as the optimum value of BTA for given settings of the neural network. In a table, we present results of IOU computations for cross points of object and background classification errors. If you compare obtained values of IOU for BTA parameter related to the cross point, we see that for network trained with minimum B probability 0.8, results of IOU do not change. This means that the value of BTA parameter is the most appropriate for further calculation and for segmentation process. And now it's the time for some pictures. First, binarization results for different B radius settings. You can easily see differences in the results in both steps, coarse and accurate. Now we can compare results for different BTA settings in the same network. The lower BTA value is chosen, the more pixels are considered as an object. And finally, the impact of BTC on binarization. You can see that the picture is covered with rectangles, which get smaller while we increase BTC value. The lower BTC value is, the more windows is analyzed, because the low threshold setting gives a suggestion that some pixels might be considered as an object candidate. And in conclusion, we found the best settings for analyzed parameters, which you can see on the screen. We presented invariance of pixel classification error computed for 3 different values of the radius. And we found out that setting the radius on of a circle with its center place on the object in such a way that some pixels captured by it do not belong to the object doesn't lead to inefficient training of the neural network. And what's the most important, our algorithm doesn't need a specific location of the center of the circle. You just have to remember that it must lie on the object. And our plans for the future, well, we think that the future is now. So we are working on modification of our algorithm to enable it to more complex object recognition and segmentation. The aim is to simplify the data preparation for any kind of object in order to use it in faster and more accurate training of neural networks. We basically plan to search for new solutions on the basis of our current research. So thank you for your time.
Thanks, Veronica, for your very interesting presentation. Are there any questions from the audience? If this is, please raise your hands, and I will give you the word. Okay. Okay, Veronica, I have one quick question. Just which are the steps of your pipeline where you think that there is more room for improvement? Because I've seen that there are different steps, and especially maybe for the preparation of the data, maybe there could be some room for improvement to move to a fully automatic procedure for that step, for example.
Well, it's quite automatic now, but well, the aim is, well, you know that bees are quite simple objects in an image, and our algorithm behave very good on such an object. And now the aim is to spread this algorithm for more complex objects, for example, like vessels and I don't know, maybe butterflies, something that is something that its shape is more complex. And I think that well, there should be more parameters put into the algorithm to manage this problem for more complex objects.
Sure. Thanks for your.
Thank you very much.
Okay, the third speaker.
Hello.
Hello. Share your screen.
Okay, so as I was.
Isn't it my turn, Marin Juliana, with the paper with cyber physical platform? Or maybe didn't get the latest change.
Sorry, please mute your microphone. Presentation. So Juliana Marin from SC InfoWorld SRL, and she's going to present. She's going to present his paper called Cyber Physical Platform for Preeclampsia Detection. So please feel free to start, Juliana, when you are ready.
Hello. Can you hear me?
Yes, perfectly.
Okay, thank you. Hello, my name is Juliana Marin. I am from the company InfoWorld from Romania, and today I'm going to talk about the cyber physical platform for preeclampsia detection. First of all, hypertension-related conditions are the most prevalent complications of pregnancy worldwide. They manifest up to 8% of the cases, and if left untreated, can lead to serious detrimental effects. Early detection of their sudden onset can help clinicians alleviate the condition and improve outcomes for both the future mother and baby. Preeclampsia is an illness which appears after 20 weeks of pregnancy and is characterized by gestational hypertension, proteinuria, and organ dysfunction. Now, regarding our work, okay, and what exists until now, today's prevalence of smartphones and cost-effective wearable technology provide new opportunities for individualized medicine. Existing devices promote health, as well as they monitor and encourage physical activity and measure sleep quality. This builds interest and encourages users to require more advanced features. One such device is H2BP, a wearable blood pressure monitor in form of a light wristband. It measures blood pressure with an accuracy of 5 millimeters Hg, mercury every 30-50 seconds, as well as heart rate with an accuracy of ±5%. While measuring, the indication is to hold the correct position in which the device is at the heart level and not to move or speak. An Android application is also available, and communication between the device and the smartphone is achieved via Bluetooth. Secondly, we have Omron, which is a heart guide blood pressure watch, which is an oscillometric wrist wearable blood pressure monitor comprised of a miniaturized components of traditional oscillometric measurements. It includes an inflating cuff, and also it takes blood pressure reading in approximately 30 seconds. Reading is triggered by pressing a button and lifting the arm to the heart level, where it must be kept during the measurement. Unlike the device presented before, we have Seismo Watch, which was introduced by Kerouac, and it measures the blood pressure via a novel technique, which employs the theory of pulse transit time. The device which is proposed by them is a wristwatch that must be held against the sternum for less than 15 seconds to detect micro vibrations of the chest wall associated with the heartbeat. Blood pressure is estimated by considering its inverse correlation with the time interval for a pulse wave to travel from a point close to the heart to a more distant location around the wrist. An accelerometer and an optical sensor of the watch measure the pulse wave travel time, and according to this, a device estimates the systolic and diastolic blood pressure. Now, the present paper details the cyber-physical system built around an intelligent bracelet for monitoring hypertension-related conditions tailored for pregnant women. The wearable bracelet device is composed of innovative biosensors that monitor the user's blood pressure. They monitor the microfluidic channel deformation based on the impedance principle. Their large size covers a sufficient area on the wrist to detect small changes in pressure as blood pushes against the wall of the radial artery. When equipped, the dedicated sensors are positioned along the peripheral artery, which is the radial artery, which takes contact and without inflating it or disturbing the blood flow. The waveform of the pulse is captured by the sensor, and it is sent to the microcontroller, which disregards corrupt data sequences caused by incorrect placement of the bracelet. Correct wafers are sent to a pair mobile device. The accompanying application determines the minimum and the maximum values based on the hill climbing method. The algorithm is implemented at mobile device level to maximize the bracelet's battery lifetime. The more important parameters obtained are the systolic and diastolic blood pressure values. The bracelet has these integrated sensors which register the waveform and send it to the user's smartphone, where the systolic and diastolic values are determined. The mobile application acts as a bridge between the bracelet and the software server. Its inclusion reduces the bracelet's weight, complexity, and cost, while it requires just a Bluetooth Low Energy chip for communication. Furthermore, it keeps end users in control of the recorded data, which can be viewed and managed through the mobile application. The risk of preeclampsia is present when persistent hypertension is detected. This is defined as systolic values are over 140 millimeters mercury, or diastolic values are over 90 millimeters Hg. These are recorded over two measurements, which are at least 6 hours apart. In this case, the mobile application can raise an alert to notify the end user to contact their physician. All recorded values are stored locally through the mobile application. Once an internet connection is available, they are sent to the application server. The server is the central repository where all the recorded blood pressure values are stored. End users and physicians access the servers from a web application that enforces role control access and ensures data privacy. The application allows all users to visualize recording values, statistical data, and alert history. The server also carries out the final and the most complex phase of data processing, where the physicians can enter additional contextual and clinical information into the system, like patient age, weight, height, if they smoke, which is the race and the cholesterol level. And these values are fed into a machine learning classifier, one of the project's innovations being in this site. The classifier is trained using the open dataset from Massachusetts University of Amherst and the National Health and Nutrition Survey. It provides a finely tuned risk profile for hypertensive conditions in pregnancy and identifies those cases that are prone to preeclampsia before physiological changes like proteinuria, which can be detected. The end user can configure the measurement frequency, mark the period of time they reserve for resting, configure how they choose to be notified. The settings are designed to provide balance between the frequency of measurement, device battery life, and to avoid the physiological observer effect. Furthermore, the values are recorded during the resting period and they are important in order to signalize risks. Now, regarding the technical challenges, one of them is the accuracy of the waveform measurement. In a permanently equipped bracelet, the research team put the device on an arm, like a regular blood pressure cuff, and one on the wrist as a watch. The main trade-off concerns the fact that the arm is closer to the heart, and at the same level it increases the likelihood of accurate readings, since technical evaluation show that a wrist-mounted bracelet produces accurate readings as it is preferred. This also have the added advantage of not looking out of the places the device resembles a fitness tracker. Additional optimizations are carried out by minimizing the battery consumption and to assure normal wear and tear that do not affect the reading accuracy or the results from the multifluidic layer. Dividing software components across the bracelet, the mobile device, and the software complements the hardware device choices, lowers the entry cost, and allows additional features related to disease identification or early warning to be evaluated and rolled out on the server side. As a conclusion, early detection of preeclampsia is paramount to give the mother the opportunity to receive proper treatment and minimize risk during pregnancy and delivery. The system is presented as part of the iBracelet European project, which aims to contribute towards decreasing hypertension and the risk related for pregnant women. Our proposal provides an end-to-end solution for continuous real-time monitoring, which combines innovative, easy-to-use piece of hardware integrated with software services which enable data collection, advanced data analysis to predict future cases of persistent hypertension, together with statistical recording. From the hardware side, we believe that the greatest improvement will be to extend the project scope in order to cover prevention and management of hypertension in the general population. The best way to achieve this is to integrate the bracelets technology into well-known wearable devices, such as we have Apple Kit 2 or Google Fit 3, and we intend to further improve classification and increase this predictive power, both in particular case for pregnant women and also for the general population. Okay, thank you. And if you have any questions.
Thanks, Juliana. So if there are any questions from the audience, please raise your hands and we can make them. Okay. So no questions from the audience. Juliana, one question from my side. So in your future plans, is there any space for any quantitative experiments with the real users to assess, for example, usability, effectiveness, and efficiency of your platform under real-world utilization?
Yes, firstly, we tested at the lab, and we also wanted to test on pregnant women. We tested on one pregnant woman, but now due to the pandemics, it's much more risky. So we are still trying,
Sure.
but in the future, we want to continue it because we have reports every year, so we wish to test.
I wish you. So thanks again, Juliana, for your presentation, and we can go through the last presentation. Bolette Hansen from Aalborg University and Envidan AS. She is will go to present a paper entitled Prediction of the Methane Production in Biogas Plants Using a Combined Gompertz and Machine Learning Model. Bolette, feel free to start when you are ready. I can see your screen.
Okay, super. Can you hear me too?
Yeah, perfectly.
Good.
Great.
Okay. Yeah. Hello. Today I will present this work on prediction of the methane production in biogas plants using a combined Gompertz and machine learning model. The work was conducted in a collaboration between Aalborg University and Envidan AS, which is a consulting engineering company. With
Please, audience, please mute your microphone if you are not going to present.
Știu că pare cu ei la chestia la prima vedere, dar e foarte profundă și te răscolește.
Julian, sorry about that. One moment. Okay, no, okay. Now, sorry for the interrupt. You can continue. Sorry.
Okay, that's fine. So first, I want to give you an introduction to biogas plants. So a biogas plant takes in a lot of different feedstocks in order to produce nature gas. In the case, and if you look at the images in the bottom of the screen, you can see an example of feedstocks coming in with a truck and then the biogas reactor. On the second images, the biogas plants that this study was made on takes in approximately 220 tons of biomass per year, and the feedstocks are mainly seawood, wheat, manure, eolate, and pectin. But it also takes in a lot of other feedstocks. So the yield of this biogas plant is approximately 10 million normal cubic meters of methane per year, which corresponds to approximately 100 gigawatt hour heat per year. So it's a quite big biogas plant. And for this biogas plant, it's very important to keep a constant production in order to meet the demand, but not avoid and still avoid overproduction as the surplus will just be burned off. So in order to keep this constant production, let's see, yes, in order to keep this constant production, the operator of the biogas plant model the methane production, and that's traditionally done by Gompertz models. And an example of a Gompertz function can be seen in the top of this slide. So if you plot a Gompertz function, you'll get something like you can see in the bottom right of the slide. And what is important in this is that there are 3 parameters that you need to set, which is lambda, the delay before any biogas is produced. Then it's the max production rate and the max gas production. And these parameters needs to be found for all of the feedstocks. And that can be really hard because you can find some in the literature, but they might not, even though they are for the same feedstock, there might be different compositions of feedstocks from different places. And there's when you co-digest, that means that if you digest more than one specific feedstock, then they can interact with each other. And if you don't have the parameters for the Gompertz functions, then you need to make an experiment or you need to make an estimate. So this means there are a lot of unknown parameters in this. If you take a look at the last image in this slide, you can see the daily production per ton of biomass for the different biomasses over time. Okay, so this would be really nice to get a more precise model than you can get with the compartment model. And in order to do that, we have made a machine learning model, in which we trained on 430 contiguous data points, and then tested on 350 data points. So in order to make the model, we made a holdout validation on the training set, where we made 25 folds and developed and tested like 7 different machine learning algorithms, and then we selected the best of the algorithms and compared it to an example of all of the best of the algorithms, and then we selected the best model. If the best of these models did not exceed a threshold for how good it should be, then it was thrown out. And if it exceeded the threshold, then we saved the model. And then we used all the saved models in order to predict on our test dataset. For the combined model, we use the compartment model and combine it with the machine learning model, where the machine learning model in this case predicted the error of the compartment model. So this is the results you can see here. The red lines indicates the measurement, the purple the compartment model, the green the machine learning model, and the blue one the combined model. And in the bottom, you can see a zoomed version where you can see that the machine learning model and the hybrid or combined model, they actually follows the measurements better than the compared model when looking one day ahead. So that's also what we could see when we calculated the mean absolute percentage error for the 3 models. Yes, and then we discovered that there was a small offset for the machine learning and the hybrid model and also the compartment model. And if we took that offset into account, then the hybrid model or the combined model performed 66% better than the compartment model. So yes, that was it. Thank you.
Okay. Great. Thanks, Bolette, for your presentation. Any question from the audience? Please raise your hands with the functionality in the platform. Two questions from my side, Bolette. Which model architecture or combination of model architecture achieved the best results? I've seen that you have used several variations of machine learning models. Have you tried by combining them 2 by 2 or 3 by 3 to see which specific model and which specific architecture gives the best way to improve the results?
We made an ensemble of those which predicted the best. So yes, but we didn't do that for all combinations of the models, because here what you can see here is the best of the models in general that we tested. We also tested a lot of other models, but these were just for initial tests.
Okay. Thanks for your answer. So again, any answer? Any question from the audience? Okay. Thanks again, Bolette, for your presentation. We have finished this session. Thanks to all the presenters and the audience for being here, and enjoy the rest of the conference with in the next hours and tomorrow.
Hi, Natalie. Just confirming, do you hear me?
Yes.
Oh, okay. Perfect.
Yes, clearly.
Thanks.
Natalia, you are the chair for the next session?
Yes, I am.
Okay, perfect.
Uh, maybe someone wants to test the system and to share the screen. You have a lot of time to do this.
That would be really great for me. Kazi, I just want to share my screen.
Yes, we can see the screen, the presentation.
Okay, and the slides are changing, right?
Yes, but we see also the chat of Jitsi. Maybe you should
Sorry?
press close the chat of Jitsi, then we will see the presentation better, the full screen maybe.
Oh, okay. Let me.
Yes, now it's okay.
Okay, perfect. Thanks.
And if you want to, yes, you can press here or you can, oh, okay, full screen now.
Hello, can you hear me?
Yes.
Okay, fine.
Good day.
Fine.
If you want, you can test sharing the screen of your presentation.
I think it works. Just a sec. Yeah, you should see it now. It's okay?
Yes.
Okay, fine.
And do we have the first presenter with us?
I am the first presenter.
Okay.
So you do have.
So the first, the second, and the third. Am I right?
Yes.
Yeah, I'm the second presenter.
So we're waiting for the fourth one. And can you say who will be the presenter of the first paper, the name, please? I can't see.
My name is Rytis. I'm substituting Rahul, who unfortunately is unable to attend due to time differences. He's traveling. So whenever you're ready, I'm also ready. I'm the second on the list of names.
Okay, now I think we will start in a minute. So I guess the fourth presenter will be on time. And now I think we will start continuing the general track 5 with the first presenter, the presenter of the first talk about the anthropomorphic robotic hand for small-scale industrial application. Please welcome.
May I start?
I think yes.
So
we hear you and see your presentation.
Okay, thank you very much. Hello, everybody. My name is Rytis, and we'll present briefly, try to condense into 10 minutes our approach on the anthropomorphic robotic hand. Basically, a very low-cost and DEI solution for small-scale projects. So the outcome you can see on the first slide, on the title slide, it looks like this. Actually, you can print it and assemble yourself. The construction was developed as open source and all the software is running under ROS. So without further ado, why do we need it? Because humanoid hands are actually the decent hands with full motion replica are actually kind of expensive. So for a research perspective, and especially for small scale projects where 5 bendable fingers are needed, it's sometimes makes common sense to experiment. So we made one out of very accessible 3D printing plastics. So basically you just some basic 3D modeling and assembly with small servo motors and leap motion as a controller to train the algorithms of gripping, touching, and so on. So basically quite a simple system, as you will be able to see in a few slides. So as for the methodology, basically we did a development of a supervised motion learning system in 4 stages. First one is, of course, data generation and pre-processing, then motion learning, then evaluation, and then, of course, motion prediction. So it is summarized in the diagram as you see on the screen. So more or less slightly modified standard robot training approach. So we had to create our own data set. It is just a fragment here. The table is quite a lot larger, but we decided to use a leap motion sensor, which we had lying around, and it's quite decent at picking up fingers, and we needed this hand to replicate human fingers, and for that it is important to detect the angle of each finger and also the precise motion of whatever shape we are trying to reproduce. So this, of course, then depends on what kind of object we want to pick up and position with our robotic hand, and of course this proprietary gripper. So basically, we retrieved angles between proximal and intermediate bone of every finger and captured this data for 150 different situations from 3 different objects: ball, rectangle, and cylinder. And these are the standard testing scenarios to test robustness of the approach. So as for the design, it's not complicated. The algorithms are based on a native Bayes classifier, and probabilities of unseen data are calculated on Gaussian probability density function, which we use to produce an estimate of probability of previous unknown input value. This is for compensation of some angles sometimes missed by the leap motion sensor, because that one also varies depending on your actual hand placement. So as for the implementation, you can see the very brief outline here. So of course, at the end, it comes up to servo controllers which bend the actual fingers. So we need to perform readings of whatever value we passed and what is the actual value of bend. So also we have an input-output interface and algorithm AI-based, light AI-based algorithm. And I mentioned MBC because of the performance. We want this hand to operate at a fast, near real-time rate. Obviously, because in whatever practical application you need speed. So you can see the other side of the hand in this picture. So here, basically, servo readings processes fetches the reading of every single servo motor as a feedback of rotational degree measurement. Our interface processes those measurements and passes basically to the computational board. Slight ARM-based FPGA was used in this case, and this is plenty for these calculations. And then the messages are passed to ROS, which controls all this stuff. Okay, so this is the concept of how the motion learning was implemented. You can see basically the representation of the 3 objects. This is the 3 for benchmarking purposes, trained at 5 different instances, acting as a sample flow from different people for initial approximation of algorithm analysis. So once we have that, basically we are able to collect the data. This is also a sample cut from what we have. So for each finger, we have the positions of the joints. So basically we are replicating the positioning of a normal human hand's finger and try to translate that onto our own proprietary DEI robotic hand. So as you can see, the approach itself is not complicated. So once we have the data, before we can actually start getting something decent, we need feature analysis and feature ranking. This picture is displayed by class separability criteria. So I will not probably detail much because I don't have much time left, but in this picture you see ball, in the other pictures you will see other different shapes. More interesting is probably this picture, which shows the distribution of the index and thumb finger angle values with 1, 2, and 3 sigma confidence values, because this shows how well the actual placement of captured data correlates with the actual positioning of the robotic hand. Because I would like to remember the goal, we need to translate the motion of the hand as accurately as possible. And you can see it's quite all right, falls within within stack. This is a distribution of the pinky finger and the ring finger angle values. It's a little bit more complex task because the fingers are more close to each other. So it's harder to separate, and it's also reflected in the measurements. So as for results, obviously, once we have everything set up, we need to measure an estimate of how well our algorithm performs in a production environment. So in the labs, we have small conveyors on which we can test and attach our robotic hand, and the hand has to grip and position a ball, cylinder, and rectangular shape. So of course, before it can do it, it must classify it and obviously output the correct action. So it's not a guarantee of performance, but probably a better, more of a measure of accuracy and efficiency. So we used tenfold cross-validation to verify the results. The mean accuracy of the object recognition achieved using native Bayes classifier was 92%, F-score 0.914. It might not seem too high, but I have to remind you that it's running on a very low computational power board, a standalone controller, FPGA based, and it runs at a very decent near real-time speed. So I think the compromise is quite decent. So this confusion matrix you see on your screen basically tells that the ball shape is the most accurately recognized and gripped. The cylinder is often confused with rectangular object class due to the similarity in shape as seen by the sensoric of the system. And receive operating characteristic curves are presented in this picture. So
you have 1 minute left.
Yeah, I'll jump to conclusions in the next slide. So just to summarize, we reached an acceptable compromise of performance and a very cheap approach which everybody can replicate with open source component, and all this stuff is also made available by us. So all we need to do is a leap motion, some servers, and a 3D printer, and basically load the code. So algorithms chosen were suitable for decent positioning and prediction of shapes, because the hand has to replicate the actual hand motion of a human person. So more or less that's it. We have 1 minute, I hope, for questions. So no questions in the chat. Maybe other people might want to ask something. Thank you.
Thank you. Any questions from the audience?
I also look at the chat, so you can type, and I can also respond later in the chat.
I have some small question. Am I right that you not use cameras or some other equipment, or just make it with hand to recognize the shape of the thing?
Yes, exactly. There are sensors later put on the hand itself, and we don't use any 3D vision or so on. It's like a human by touch. Basically, you grab the object. So the sensor leap motion was used for training for getting the coordinates of the live human hand, but other than that, the hand does not, let's say, for object classification, for the shape classification, the camera was not used. Later, of course, once the conveyor is running, the hand is steered using the camera feed, but that's a different task. The grip itself was implemented without the actual camera, only on leap motion data.
Okay, thank you for the explanation.
Sure, you're welcome.
I have a small question. So you said that your results are accessible, so it's available somewhere on the net and you have the links published.
It should be published pretty soon, as long as the paper is published.
Oh, it's in the paper.
Yeah, it will be synced parallelly to it.
So to reproduce your results, we need to have a 3D printer and the special leap motion sensors.
Yeah, the leap motion sensor is not just anything you can buy online on any major computer shop. If they sell it. It's just a small device you plug into USB, and some laptops had it. I think HPs had it integrated. But we just got it lying around, and we used whatever we have.
Okay, and is something else is needed to build the system like yours?
No, it's off-the-shelf components. Standard servos, small servos you can get probably in any electronic shop.
Okay, thank you.
Sure, you're welcome.
Are there any other questions? If not, that we will thank the speaker again and turn to the next presenter, Kazi Adnan, with his presentation about the ADMM approach for constructing a abnormal subspace of sparse PCI. Welcome.
Perfect. Thank you. Do you see my screen and you can hear me?
Yes.
Yes, perfectly.
Okay, perfect. Perfect. Thanks. So, yep, that's good. So, good afternoon, everyone. Though it's afternoon in Italy, it's really early morning in Melbourne, like 1:45 a.m. My name is Kazi, and I'm working as a casual academic at the University of Melbourne in Australia. Today, I'm going to talk about our proposed ADMM approach for constructing abnormal subspace of sparse PCA. So this is the outline of my talk today. I'll start with the goal of this work, leading to motivate why this work is important and what is our contribution. Then I'll talk briefly about the methodology and the findings of the experiments and finish with some concluding remarks. So in this work, our goal is clear and simple. We want to do anomaly detection using the abnormal subspace in an unsupervised fashion. At the same time, our aim is to interpret those anomalies, pinpointing the cause of the abnormality. So if we talk about unsupervised anomaly detection, then we really have to start from PCA. So PCA is a well-known method for dimension reduction and widely used for anomaly detection in different domains. But this suffers from interpretability due to its non-sparse nature and has a weakness in higher dimension. So therefore, people introduce different methodologies such as sparse PCA, ASPCA to improve the interpretability, but they either suffer from interpreting individual anomalies or computational inefficiency. So in this work, our aim is to create an abnormal subspace representing anomalies. So we are using the least significant principal components with an adaptive deflation technique. So the objective is to find sparse, least significant loading vectors explaining minimum variance, which represents the anomalies of the dataset. The sparsity and the orthogonality constraints makes it hard to compute the subspace, but really special thanks to ADMM, alternating direction method of multipliers, which is an efficient, distributed, effective optimization tool that helped us to find abnormal sparse principal components representing each of the anomaly types. So this leads to our contribution. So we have derived an ADMM solution for backward ASPCA, extracting least significant loading vectors. We have concentrated in minimum variance using an adaptive deflation technique. And our proposed approach achieved comparable detection accuracy with state-of-the-art methods in real-world datasets. And most importantly, it is 10 times more efficient in terms of computation than a semi-definite problem formulation. So now we will briefly talk about our methodology in this slide. So our objective, as we have to find abnormal subspace explaining the minimum variance. So we have represented subspace by orthogonal and sparse loading vectors, or you can say bases of the subspace. So we aim to find those loading vectors sequentially, to be precise, one by one, ensuring sparsity and orthogonality constraint. In this work, we detect anomalies using square length of projection, or you can say like the residual length in abnormal principal components. And all the objective functions to capture the lowest variance and all the steps and propositions we have detailed in the paper. So as we said, we know ADMM is a distributed scalable algorithm that solves convex optimization problems jointly by breaking them into smaller pieces. Then what happens is that each of those are easier to handle. So we are using ADMM to solve this optimization problem here. So in this slide, what we did is like we highlighted the optimization problem of finding the least significant loading vectors, the corresponding ADMM formulation, and the updates of each of the variable in the formulation. So this is the proposed algorithm where it takes the input of abnormal subspace parameter, the sparsity parameter, and the Lagrangian penalty parameter, and the output is the abnormal subspace of least significant sparse principal components. So before jumping into the result, let's look into our experiment settings, which is really important. So we have incorporated our proposed approach with 3 baseline models, PCA, SDPP, which is the backward ASPCA with semi-definite programming, and ADMMA, which also finds abnormal subspace, but it finds species simultaneously. And for the dataset, we have used the breast cancer dataset, which has 2.72% anomalies, and the KDD99 network intrusion dataset, which has 0.17% anomalies. And for the evaluation, what we did, we evaluated the proposed approach in terms of anomaly detection, runtime efficiency, and last but not the least is the sparsity. So sparsity we have defined as the L1 norm and the cardinality of the loading vectors. So our proposed approach achieves similar accuracy in terms of anomaly detection. The top 2 ROC curves on the top left is the breast cancer dataset ROC curve, and the KDD99 network intrusion dataset on the right hand side. We can see that various ASPCA models achieve similar detection as the standard PC model, indicated by the similarities in their ROC curves for both of the datasets. So it guarantees that our proposed approach finds the anomalies. Now we need to evaluate the sparsity has been ensured or not. If you look at the bottom left table, this reports the sparsity performance of the models considered here. And you will see that our proposed approach, ADMMD, provides sparse species evaluated in terms of L1 norms and the cardinality. And this is true actually for both of the datasets. Now, if you look at the bottom right table, which shows the runtime performance of the models, the good news is also here, as the runtime in the proposed approach is 10 times efficient than the state-of-the-art semi-definite programming approach. But if you look into that, if you look and note that ADMMA has even better runtime efficiency, as it estimates the whole subspace simultaneously rather than finding principal components one by one. But that state-of-the-art method has a problem in terms of interpretability because it does not guarantee sparsity in their individual pieces. But our proposed ADMMB approach ensures sparsity and also efficient in terms of computation. So to summarize what I have talked about today is we propose an ADMM approach for anomaly detection and interpretation. This approach extracts abnormal subspace with sparse and orthogonal principal components, and this is 10 times efficient than the state-of-the-art semi-definite programming solution. This approach can be applied to any datasets with high dimension due to its computational efficiency. In future, our aim is to apply the proposed model in different domains with higher feature dimensions. So this slide highlights few of our major references we have used in this work. Now I'm happy to take any questions. Thank you so much for listening to my talk. Feel free to reach out through the email if you have any queries in the future. Thank you.
Thank you. And are there any questions from the audience?
I have a small question, if I can.
Yes, of course.
Sure.
So there is a popular algorithm for anomaly detection isolation forest. So I wonder if you can compare your approach with that one. So why is your one better in what cases?
Okay, isolation forest. Okay, so maybe that's a good improvement. We can compare that in future. Yes, I'll make a note.
Okay, thank you.
Isha, thank you.
Other questions?
Any more? Yep.
Maybe no questions more.
So the thing is, like, we compared with 3 other methods, but not the isolation forest. But yeah, that's a good comment. We can do that. Sure.
There are many different algorithms, so I just wonder
Yeah,
maybe
true.
specific cases when your algorithm is really better and you show it, or maybe it's not applicable somehow. So just because I had some experience with that one. Okay, thank you.
Sure. I really appreciate that. Thanks, Gio.
Thank you very much, and I think we'll move to the next presentation.
Yes. Can you see me and hear?
Yes.
I will share my presentation.
Okay, and the next speaker is Nicolas Silva with his work how to improve the recommendations accuracy in POR domains. Please welcome.
Okay, can you see my presentation?
Yes, we can.
Okay, thank you. Hello, everyone. I'm Nicolas, a PhD student of Federal University of Minas Gerais from Brazil. And I'm here to talk about this paper entitled How to Improve the Recommendations Accuracy in POI Domains. First of all, it's important to know that nowadays recommender systems play an important role in many web services. In addition to other factors that justify this importance, we can highlight its ability to provide personalized content by identifying relevant items for distinct users. I'm talking about the recommendation of movies in Netflix, products in Amazon, and even publications in Facebook. And most recently, the recommendation of points of interest like restaurants, bars, museums, and others in social networks like Yelp. Although the similarity between these domains, POI recommendation is more challenging than the other domains. The main reason is because in this case, we have to consider many other factors to provide recommendations. There is a context like the weekday, the hour, the proposal, and that must be considered by the method. And there is the influence of social networks, especially our friends' opinion, and also the geographic location, because most of users prefer to visit places located near their home or their workplace. So in this sense, several works have been proposed distinct strategies by considering these factors. There are some algorithms like USG that combine social and geographical information, GeoMF that provides a matrix factorization by considering geographical information, and also GeoSoca that combines geographical, social, and categorical information to provide recommendations. However, even these recommender systems designed specifically for this domain, they have not achieved significant improvements in accuracy terms. The domain is more challenged than the traditional domains of recommendation. So we propose to face this challenge in another way. Basically, we propose a reordering method to be applied after any recommender system strategy and improve the recommendations accuracy. Our method is based on the user activity level in distinct sub-areas of a city. Our idea is to give more relevance for POIs located in sub-areas that have been visited by the user. we hypothesize that users have more preference for points located in places that they have visited a lot in the records. So our method, for this reason, we named our method as geofiltering approach, and it works as follows. First, we split a city into many sub-areas of, for example, 0.5 square kilometers, like in this figure. And then for each user, we measure the user activity level by the relative number of users visits in each sub-area. It's similar to this equation. It's basically the frequency of user visits in this sub-area normalized by the total of visits performed by the user. So we have a number that represents the importance of this sub-area for a specific user. This strategy is then applied to improve the recommendation list of any other strategy. Basically, we run a base recommender that can be anyone to generate a temporary recommendation list that will be processed by our method by geofiltering and processed to emphasize the more relevant points in the final recommendation list. So this process is similar to it. And this process is made by this main rule that emphasizes the score of points, the relevance score determined by the base recommender. Our method will emphasize this score for points that are located in relevant sub-areas for some users, while it also will decrease the relevancy score of points located in sub-areas that are not visited by this user. So for this, in order to evaluate our proposal, we selected 3 main cities from Yelp challenge datasets, Las Vegas, Phoenix, and Charlotte, that have this number of users, points, and sparsity, and where points have at least 5 check-ins and the users have made at least 20 visits. And we use this data to generate the training test sets. And moreover, we selected 6 base recommenders to analyze the improvements of geofiltering by some accuracy metrics that are very common in the recommendation domain. And 3 of these recommenders are developed for the traditional scenarios. They are most popular, user KNN and WRMF. And other 3 recommenders that are developed for the specifically domain of POIS recommendations, USG, GeoMF, and GeoSoca. So we analyzed for each city the metrics, the results of precision, recall, and DCG and MRR with the application of the base recommender, like most popular, user KN, WRMF, and also with the application of our method, that is a post-processing of these other recommenders. And we are interested into significant gains of accuracy achieved by our method. And as you can see, in most of analysis, our method achieves improvements. This green arrow represents significant improvements by the Wilcoxon test. So, as you can see, our method achieves improvements in our algorithms in most of the cities, in most of the scenarios. And the same thing happened with considering the recommender designed specifically for the POIS scenarios. Our method also achieves significant improvements. The only exception is with the application of our method after the GeoSoca, because we think that it's happened because GeoSoca is a method that combines a lot of factors like geographical, social, and categorical information. And our method is only based on the geographical information. So we think that our approach over-specialized on the geographical information and ignore the other factors. So this is only the algorithm that we cannot improve in across terms. So indeed, we find that a reordering method seems an interesting approach for POI scenarios. Our method especially achieves improvements up to 15% concerning the across metrics. And as future work, we intend to achieve more improvements by considering other relevant factors for POI recommendations, like the context, the categorical and social information. So this is some reference, and thank you for your attention.
Thank you very much. Are there questions from the audience? Oh, so I have a question. Maybe I don't understand clearly. You look for people visiting some places by doing this by the map, not the GPS position, or maybe I just don't understand clearly.
Yes, we just count the number, the frequency of visits that a specific user did in some places. And we have the location of these places. So we can map the city, the specific location that this user is visiting. So we can define these sub-areas and define how important is each sub-area for a specific user.
And you are just collecting some statistics, or you will then make some recommendations for some places to visit, like the places the person often visits before.
Yes, we receive the recommendations of any recommendation strategy, and we improve, we reorder these recommendations, these places for the users based on their location, based on the location that are more important for the user. It's basically related to our assumption that users will prefer to visit places that are near from their location, their current location, or near from their home or from their workplace. Okay.
Yes, thank you. I understand. Are there other questions? Then let's thank the speaker again. And I don't understand if we have the last speaker with us, or yet some technical problems.
I have a technical problem.
So should we wait for him changing the device, but it was long ago, I think. I think then we'll close this section and we'll see in 20 minutes maybe last presentation. Okay, great. So we have the last presenter with the work of pure learning-based forwarding strategy in named data networks. Please, you're welcome.
Okay, thank you. Sorry for the technical problem.
It's okay, we can hear you, and we are waiting for your presentation. Yes, we can see it.
So our presentation deals with the Q-learning based forwarding strategy in name data network. This is the outline of our presentation. First, we will introduce a new communication paradigm, which is the name data network. It's a new data-centric architecture that redesigns the internet communication paradigm from IP address-based model to network performance in dynamic environments. NDN introduces a new communication model. In fact, in this model, each NDN router will maintain three structures, which are the content store, in which we save the copy of the content, and the PIT, which is the pending interest table, in which we store the waiting interest and the pending phases. Finally, the third structure is the forwarding information base, in which all prefixes are stored and the respective forwarding interface are enumerated. In this example, we see here if the consumer one requests data, initially the router has empty copy of this data in the content store, so the data would be served by the original producer. When the data reaches the router, it will be stored in the router. Then later, when consumer 2 requests the same data, it will be served not from the original producer, but from the intermediate router. This is the main communication model of named data network. Now our work here is to adapt or to improve the forwarding process of NDN by introducing the Q-learning technique. The proposed approach is called Q-learning based forwarding strategy. The aim of this our proposal is to help the NDN router to find the suitable next hop and to adapt quickly its forwarding decision according to network condition. A basic component of Q-learning is how to compute the key values. In our solution, we choose to compute these key values based on the reward and the maximum key value of the next hop neighbors. So to get this value, the maximum key value, we modify the data package structure of NDN by defining a new field that we called max Q tag, in which each router will give back its maximum key value to its neighbor. Then to compute the rewards, we use the following proposal. The reward in our solution depends on the on the interest to data delay, which we call it the IDD, and also on the loss and failure events. For example, if the data is received within a delay that is lower than the IDD mean, then a high reward will be applied. If the data is received within a delay that is higher than the maximum IDD, then a low penalty is applied. Also, if a timeout event or a negative acknowledgement event is perceived, a penalty is applied and the reward will decrease. Also, in our solution, we define three phases: the initial training, the training, and then the exploitation phase. The system continuously switch between the training and the exploitation phase. In the training, the system will try to learn and the to make its forwarding decision. In the third part, we evaluate our solution. We implement it in the named data network simulator NDNC, and we use the following topology in which a consumer requests data from a producer, and we have three routers in the middle. We compare our solution to the basic forwarding strategy that is deployed in NDN. And we explore two scenarios. In the first one, there aren't any link failure, and in the second one, we apply link failure during this simulation. The link failure is applied between router 1 and router 3, and we evaluated the following metrics. We evaluated the number of satisfied interest, which means the number of data received by the consumer. Then we compute or we compare the number of timed out interest, which means the interest that for which we don't receive any data. And finally, we compared the number of out interest per interface, which mean how many interfaces are forwarded from each interface of router 1. The obtained results are as follows. Here we see that for the best route strategy, the yellow curve, when the link failure is applied, the number of satisfied interest decreases to 0. However, with QLFS, the number of satisfied interest is not affected. In fact. For the second matrix, the number of timed out interest, we see here that with QLFS we haven't any interest that is not satisfied. The number of timed out interest is 0. However, when the link failure is applied between second 12 to 80, the number of timed out interest with best route reached 100 interests. All the interests are lost. Finally, the third metric, which is the number of interests forwarded per each interface of the router. In the figure on the left, here the performance of best route. Now we see that best route forwards all the interests from the interface 2 second, the interface linked to router 2. However, with QLFS, when the link failure finally, as a conclusion, we recall that in our work we proposed a new interest forwarding strategy which is based on Q-learning, and we applied it in the context forwarding decision according to the delivery time and to the perceived loss event, link failure or congestion events. We compared our strategy to the basic forwarding strategy, which is already deployed in NDN, which is best route. And we found that QLFS achieves better performance in terms of speed of finding an alternative path when the initial path is interrupted. Also, QLFS significantly and finally, as a perspective in future work, we plan to evaluate our proposal in more complex scenarios. And thank you for your attention.
Thank you. And other questions from the audience?
May I ask one?
Of course.
What happens if there is a data packet loss? The algorithm did not illustrate that. to assume between your nodes there is a packet loss. How you handle that? Thank you.
Oh, maybe they don't hear the question.
I will type in chat, so just in case.
Sorry, if you are listening to us, we don't hear you. We hope that you hear our presentation. Okay.
I think they didn't see the question in the chat. Maybe.
Sorry, we see you, but we don't hear you. I don't know.
So maybe you should repeat your question in the chat again.
Okay. What happened? In case, how it is handled between each node. Okay. In fact, if a data packet is lost, the corresponding interest will expire. Hence, the consumer should retransmit this his request. So it is handled by and regarding our the QLFS strategy, this event will be this action will be penalized by applying a severe penalty. Hence, the router will no more send forward interest from this interface. It will choose another alternative. What do you mean by sorry, data? Was there a data compensation mechanism? Compensation, what do you mean by, sorry, data compensation? Okay, you can, okay. Yes. No. Okay. In fact, no, we don't handle this this scenario. The only solution is to retransmit the data. The only solution one of the cache in the router will retransmit the lost data. In fact, the caching mechanism will help us to retransmit the data not from the producer, the original producer, but the nearest router that cached the data before it was lost.
I think
Thank
we
you very
have.
much. Thank you very much.
Thank you. And I think we have no time for more questions, and we have 5 minutes rest, and then continue the last part of general track 5. Thank you for participating, and thank you for all the speakers. See you soon.
Thank you.
Thank you. See you.
See you.
So we have some minutes left. At the present of the first presentation here. Great.
It's working. You hear me?
Yes, we can hear you.
Okay.
So I think we will start continuing our workshop, our session, and let me know if the first speaker is ready. So first presentation is about the academic social networks. Are there any? Yes, okay. So the first presentation will be investigating the potential of data from an academic social networks GPS. So please welcome. We can see a presentation, but maybe not hear you. I think you should return to the Jitsi, to the browser, and turn on the microphone from there.
Unmute the microphone, please. In Jitsi.
Now can you hear me?
I think we can hear, but not good.
Can you hear me?
Not good.
I think you can move to the next speaker. I tried to go to another place.
Maybe you should keep closer to the microphone.
Yes, let me see.
The voice is too low.
The speaker told that he will change the device and propose to go to the second speaker.
Thank you, Elena.
Sorry, can you hear me?
Not good enough. No, practically not. No. No sound at all. Okay. If yet no sound. Oh, yet no. So I think that now we're turn to the second speaker, and you will try to solve the problem. So our next speaker is Alexis Ariola with the work on large-scale internet user behavior analysis of nationwide K-12 education network based on DNS queries. Please welcome. Yes, we can see the presentation, but
Okay,
not hear.
okay.
And now hear you. But we lost the presentation. Okay, yes.
You can see the presentation?
Yes, can see and hear.
Okay. Well, hello everyone. My name is Alexis Arriola. I am a student of Universidad de la República in Montevideo, Uruguay, and I'm one of the authors of this work, large-scale internet user behavior analysis of a nationwide K-12 education network, based on these DNS queries. First, a little introduction. The importance of internet access to education has significantly increased in recent years. In 2007, Uruguay started Plan Ceibal, a national K-12 education service provider, which main proposal is wireless connectivity. That's all the students between 6 and 18 years old to connect to different resources, including internet access. The goal of this work is to study Plan Ceibal users' internet behavior through the recognition of relevant patterns in DNS queries by using unsupervised machine learning techniques. Recently, Plan Ceibal has incorporated a cloud-based DNS solution, Cisco Umbrella. One of the advantages of this new solution is possible to access in a very simple way all the records of the DNS query processing. We analyzed approximately 9.1 billion DNS queries records collected from March to May in the past year, from school and high school around the country. Also, the DNS system labels each query with a predefined category based on the URL consulted. For example, for Instagram domain, the system labels the query with the social network photo sharing category. In case of Google, is search engine. And then all queries are stored in a Hortonworks data platform. And then we use Spark to do a pre-processing of data and creating a small matrix. First, we try to identify the different age group behavior of stable users. For this reason, we built a matrix in which each row represents the type of educational center for school or high school per state, and the columns are the principal categories that the system of DNS used to label each query. This data matrix was the input of the PCA, performed to decrease the dimensionality and had a better visualization of the observation. And coming clustering tackled to identify different group behaviors. Two clusters were identified, one for a school data point that is in gray color, and the other is a high school data point that is in green color. This representation proves the different pattern between these two age groups. In other words, kids and teenagers clearly have a different internet use behavior. Then, considering the result of the previous study, it was decided to separate the dataset and maximize the school and high school observation independently. For this reason, two data matrices were built with 24 hours of the day as row, and the categories previously mentioned as column. In both cases, three clusters were identified. One that represents the school hours, that is in morning and afternoon. Another two are evening and late nights. The audience plot analyzes the role of all the variables, in the case the categories, in the two pieces choices, and their correlations and the relationship with the day hours. It's worth noting that in both cases, all the vectors are oriented toward the cluster that represents the class hour, showing the extensive internet use is exclusively for school activity. For more educational institutions and social networking, vectors are almost orthogonal, showing their independence. Then a schema analysis was used as complementary analytic tool based on previous results. We decided to consider data matrix in which each day of the week, Monday to Friday, was divided in 3 hour groups, morning, afternoon, and evening. From the two schema considering the less dendrogram, it is noteworthy that the 3 hour group are perfectly identified. Furthermore, the internet use is very low during the evening or late night hours. In case of school, it is interesting to see that video sharing, games, photo sharing, social network occurs more during the afternoon hours, in particular on Saturday and Friday afternoon, and that is in the end of the week. While education institution is quite more during the morning all week long. In the other hand, in high school, Saturday and Saturday afternoon are the time window with more activity, and teenagers, unlike kids, use video sharing, social network, and photo sharing during the classes hours. Finally, the conclusion, the result shows that internet use behavior is strongly dependent by age group and time of the day, and in a depth analysis presented that students' internet use behavior depends on the classes schedule, which is highly variably dependent on the education center. The analysis of the user behavior in internet access is important for any service provider, and the contribution in the particular education content is not only relevant from the notebook operator perspective, but also for the other study, combining different resources of information for learning analytics purpose. Okay, this is all. Thank you.
Thank you. Questions from the audience? So maybe I have a question, maybe I not understand clearly. You just collecting the information or give the recommendations and to give the recommendations only to the timetable for the students or for some other purposes?
Now we are collecting and analyzing the data, and in the future or in other analysis that we want to do, the goal is like you said, give an advisor or give more information to the education provider to help there to improve the education platform.
Okay, thank you. More questions? No more questions, I think. Thank you very much. And can we return to our first speaker, or we're going to the next, the third one? Still problems with microphone? I can hear something, but not clear. So maybe we will start with the third speaker and
For the first speaker, maybe he can also connect with the phone and send sound with the phone and show the slides. Yeah, did you try that?
Yes, I think.
Yes, so it's not working.
Just to upload in the application, download in the application, yeah. So I think we will start with the third speaker, and maybe you will be the fourth. The presenter of the next work on supervised learning is here.
Hi, my name is Eduardo, and it's my turn now.
Okay, you are ready to present?
Yeah, I'm ready, but just to confirm, because of the time zone, it's my turn now, for sure?
We have problem with the first speaker, so if you are ready, you can start presenting the work now.
All right, let me share.
Okay, I will announce that our next presenter is Eduardo Nagao with the work on supervised learning and feature extraction in hyperspatial imagery.
Okay.
So please welcome.
Can you hear me? Oh, okay. Please move on. I'll be the next one to present. I think I'll benefit this new device. Thank you.
Okay, great. So please, Eduardo.
Okay.
We can see your presentation and hear you clearly.
Okay, thank you all. So now the intention is to briefly speak about our work. Me and Professor Alexandre from Federal University of São Carlos, Brazil. We developed a study on unsupervised learning and unsupervised feature extraction in hyperspectral imagery. Okay. So, first of all, what is briefly hyperspectral images? They are remote sensing images where each pixel of D reflectance bands is represented by a D-dimensional vector, okay? So the ith coordinate is the reflectance value at the ith band, just like that. The special case in hyperspectral images is that D is in the order of hundreds, like 150, 200. And the point is, this implies in smooth transitions in the special spectral domains. These smooth transitions have the advantage of detecting subtle differences and evidencing this difference, which is a benefit for precision applications, okay? But the problems is that values in neighboring locations and wavelengths are highly correlated. So this causes higher interclass variability and lower interclass variability, right? The linear independence assumption in the basis vectors of Euclidean space can be not suitable as well in this scenario. And possible statistical independence assumption is not suitable as well. So because of these problems, there is a suspicion of curse of dimensionality or occurrence, okay? Curse of dimensionality can be viewed from two point of views. First one is machine learning point of view. That is about the relation between number of features and number of samples needed to estimate a function. And here this phenomena evidence the point of this relation where estimation degradation is observed, right? From geometric point of view, in curse of dimensionality, presence occurs data concentration in details of normal distributions instead of the means. The curse of dimensionality in geometric point of view is understood also as an empty space or concentration phenomena because space becomes almost empty because all the data starts to concentrate in the corners of the structures because of the rise of dimensionality. So, because of empty space phenomena, there is a difficulty in nearest neighbor definition. And Euclidean norm loses its discriminative power as well, okay? Consequently, the linear dimensionality reduction methods can be compromised because they use Euclidean assumption. And the Gaussian mixture model clustering method can be compromised also because it uses Euclidean distance, nearest neighbor search, and normal distribution. All right, but we can take advantage of some other properties of curse of dimensionality. Okay, thank you. There was microphone. Because an ill condition covariance matrix, in an ill condition covariance matrix, few space directions retain most of the variance. And because of the empty space phenomena also, data can be projected into lower dimensions without loss on classifiability, with variability conservation, and also projections tends to form normal distributions, okay? So our goal is to verify the benefit of unsupervised feature extraction previous to Gaussian mixture model clustering in hyperspectral images. Additionally, we want to investigate the benefit of nonlinear extraction compared to linear. In order to do this, our methodology was the following. We use a set of 7 hyperspectral images, and for each image we deployed unsupervised feature extraction in linear fashion by principal component analysis, that is the pioneer method in this category. And also we deployed nonlinear methods, isometric feature mapping and locally linear embedding, that is a global and a local method respectively, because they are pioneering methods also. So in the original image representation, in the PCA, ISOMAP, and LLE, in all 4, we deployed Gaussian mixture model clustering. Several executions because of the non-effect of random centroids initialization. And in all these results, we deployed 5 different external clustering measures. These measures here. And we take the maximum value between all the GMM executions for representative value in each measure. Then we would like to know if there was a statistical difference between the different approaches here in data representation, considering all these evaluations. So we use the called multiple comparison, non-parametric statistical tests, hypothesis tests, okay? We use the post hoc approach. So we deployed Friedman test and then Nemini test in the following fashion. Here, it's a particular table for each image that we used, okay? So we have Botswana, Pavia in Africa, okay? Pavia University, Pavia in Italy, Kennedy Space Center, and Salinas A in particular. Here is the table of Friedman tests, which is corresponding p-values. Notice that just for Salinas and Indian Pines, there was a p-value superior than 0.05, which indicates there was no difference between different approaches here, right? No pair of approaches indicates statistical difference for these two images. So these two images, we don't even put the table results here. But for all the others, their p-values was under 0.05. So for some pair, there was a difference. So we deployed Nemini following to identify which pairs between approaches here were significantly different. So here for Botswana, for example, we can see that NDR compared to ISOMAP, there was a difference. So if we go here to Botswana results, we see that ISOMAP has the best results in external measures for all the measures. So we can say, for example, that ISOMAP was better than no deployment of dimensionality reduction in this case, okay? Here we can say also that ISOMAP was better than PCA, right? So following the same reasoning, using these Nemini tables and using these other tables here with these values, we could find that dimensionality reduction, in our case, unsupervised feature extraction, benefits clustering by Gaussian mixture model for most images, right? And this is empirical evidence, of course, of dimensionality presence in hyperspectral images. So for most images, because here we have one case that DR is superior than NDR, 2, 3, 4, 5 cases between 7, indicating that DR was better than NDR. And we find also that nonlinear methods are superior than linear, because for most images where DR was significant, we have a nonlinear method superior than a linear. For example, here ISOMAP was better than PCA, LLE better than PCA also. Here is the one case, it's the only case that PCA was better than nonlinear methods. Here we have a nonlinear winning also between the linear, and here we have no comparison between different categories. So we could conclude these two things here, right? That's it.
Thank you. Questions from the audience? Well, I think no questions.
Okay.
Thank you for your presentation.
Thank you all.
And can we start from the first presentation? Can we return to the first speaker? Okay.
You cannot hear me?
Okay,
Yes, we can hear you.
You can hear me now?
Yes.
Okay, so let me try to share.
Okay.
Can you see my screen?
Yes.
Yes.
Okay, let's try. sorry for this inconvenience. I was victim of the Murphy's Law. So good afternoon or good morning or good night, depending on where you are. So my name is João Marques. I'm from the University of Aveiro. And as you can see, this is a joint work of other colleagues and on behalf of the team that developed this project, because the GPS it's a project that involved many people and many institutions. So I'm presenting the potential of this platform and some data that was stored by this social network. So in short, GPS is an academic network that connects Portuguese research around the world. And this particular paper assumes two main objectives. In one side, the idea is to present a GPS platform, highlighting its potential in order to characterize as well the GPS community based on the data stored by this platform. And the information collected from the members registered in the platform allow to characterize the special patterns of mobility of the Portuguese researchers across the world. These analyses focused on three main dimensions of spatial mobility. The evolution of the GPS scientists across the world, their socioeconomic characteristics, more specifically sex and age, and finally the kind of research that
maybe still some connection problems. We can't hear you.
Or specifically the place at any specific time they develop their research experience. Its structure encompasses three complementary levels. It's not time to precise or to explain in detail these three levels, but just to give you an idea, the communities are the macro organizing entities defined by default. It's also possible to create groups joining together users with common backgrounds, interests, or characteristics. And finally, and more important, it's possible to create. So each research member can create a profile where they can share relevant information about themselves. In the professional information field, the GPS member can insert location and the name of research institution where they have been working, indicating the dates of their stay in that specific location. They can also choose their scientific fields according to different 6 categories. And also, beside these categories, before the position, beside these categories, it's possible to select other sub areas. Then the members on the platform can also describe their scientific experience at the specific workplace according to 8 different categories. Based on this information, this social network not only facilitates interaction and the exchange of information between people, but also allow to collect valuable geographical data concerning the mobility trajectory of the Portuguese scientific community. Now it's time to present some statistical analysis that allow to characterize the GPS community. The results of this empirical research provide interesting insights into the international dimension of the research careers of GPS members, emphasizing some aspects like as described in this slide. How many users are in the GPS platform? Who the GPS scientists are? What have they been doing? Where have they been working? And additionally, in this work, it was applied some inferential statistical analysis in order to define the Portuguese research profile by continent and by country. I'm presenting now some results for the questions mentioned before. And this particular figure showed the chronological evolution of the GPS scientists according to position held. And from the information that you can see in the graph, we can see that the most representative categories are PhD researcher and PhD students. However, these two categories had different evolution patterns along the time. I'm having here a problem. Can you hear me?
Yes, we can still hear you.
Can you hear me? Yes?
Yes.
Okay, sorry for this. This figure shows the distribution of the research area of the GPS scientists. This field is not mandatory. Just to give you an idea, 8% of the total did not link themselves with any scientific area, and there is no restriction in the number of research that GPS can include it. So in this sample, for instance, 57 identify only one scientific area, while 35% select two or more scientific areas. And you can see the category natural science is the most representative research area. This graph shows the geographical distribution of the research experience. The United Kingdom is the most popular destination with 785 research experiences, representing around 20% of the total, followed by United States and Germany and France. GPS scientists are spread across all continents. For instance, in Europe, 25 different countries were the destination of GPS scientists. The other most popular continents is America and more specifically North America. So in this case, we have used the most appropriate parametric and non-parametric inferential tests. And this figure shows the main characteristics that emerge in each continent using that analysis. The socio-economic characteristics, age and sex, the position held, and the scientific research area that drives this experience are compared in different geographical units. So the results of this analysis provide valuable insights concerning the mobility patterns of the Portuguese researcher. Just to give you an example, for instance, when comparing Europe with the other regions, significant differences emerge. There is a predominance of women, young people, and PhD students. So in this case, in Europe, there were no scientific research area identifiable as significant, suggesting that it's not there's no specific demand for any research area. And we did the same for the most important countries. As you can see, the four most important receiving countries of the Portuguese diaspora was United Kingdom, United States, America, and Germany and France. And for example, in UK, there is a predominant presence of women, young people, PhD researchers. Social sciences is the scientific research area identifiable as significant. Now, just to conclude, as mentioned in the beginning of this presentation, so the idea was to show the added value of the GPS platform as a data source. It provides, in our opinion, an opportunity to study the main special patterns of Portuguese academic researchers around the world, monitoring their professional research career. In summary, the GPS platform creates and promotes an intensive environment of collaboration, but at some times is a powerful tool for mobility studies and for science policy making. In terms of the results, and in line with our common perception, the results of these studies show the growing mobility of Portuguese scientists, which is also highlighted by some previous studies. However, we must highlight the valuable alternative of this platform in order to allow to monitoring in an ongoing process the academic trajectory, or better saying, the academic mobility around the world. Thank you very much, and sorry for this inconvenience.
It's okay, thank you. Questions from the audience?
I will try.
Yes, please.
Yes, and what practical, your information is very interesting, thank you. Great. But what practical results can, for example, administration of the university can expect from your results?
So, since you have the data of these members, it is possible to, as I show, to know how many are they, where are they, and what they are doing. And since we have this list, it's possible to apply, for example, specific surveys, trying to analyze what would be the reasons to return back to Portugal or not. So I should highlight three main opportunities of this platform. One is putting together all the members that are registered there. Second is trying to monitoring their trajectories, as I said in the presentation. And third, it's also possible to apply specific surveys in order to know about their feelings, their willingness, and their hope to return or not return to Portugal.
Thank you.
Thank you. Very welcome.
Some other questions? So I have for some, as I understand, right? This system is only for Portuguese scientists, yes?
Sorry, Natalia, could you repeat? I cannot.
Yes, of course. This system is only for Portuguese scientists.
It is, yes.
And do you collect the information automatically, or it is provided by the scientists themselves?
So the registration is volunteer, and also the information that each of the GPS members share is also is not mandatory. There are some fields that are mandatory, but some other are not. But of course, I should say that this is the weakness of this platform, because we don't have an exhaustive data about all the Portuguese diaspora. But at least we have very interesting data that could be explored in terms of public policy in the way I mentioned before.
Okay, thank you. And maybe not a question, but a remark. Do you think it is no problem with the name of this platform, GPS, and if it is not seen that it is the Portuguese scientists, it can be understand as the GPS monitoring.
Good question, Natalia, but I'm not the right person to answer it, because I'm a small piece of the research. Just to give you an idea, many important Portuguese institutions were involved in investing on this. For example, the Telecom Portuguese Foundation, so many two universities. And when I arrived to this project, so all these labels were already defined, but I'm sure that they have registered this platform with this specific name, and they didn't have any kind of problem.
So yes, it wasn't a question; it was a remark. But yes,
thank you
very much. So our last presenter, I think we still have it with us. The last for today presentation is about the cost accuracy balance. Do we have? Yes. So please welcome Divina Gavenda with the talk of factors affecting the cost to accuracy balance for real-time video-based action recognition. We can see your presentation.
Okay, can you hear me?
Yes, and here too.
All right, great. Good evening, everyone. My name is Divina Gavenda, and I'm from the University of KwaZulu-Natal in South Africa. And I'm very happy to be here today to present the paper titled Factors Affecting the Cost to Accuracy Balance for Real-Time Video-Based Action Recognition. So just an overview of the presentation. I'll start by introducing the background as well as the purpose of the study, then move on to highlight the methods and materials used to identify the factors. Then we'll discuss the results obtained during experimentation, and finally conclude and outline future work directions. So the aim of action recognition is to autonomously classify what is being done by observable agents in a scene. And video-based action recognition in particular is one of the most challenging problem areas in computer vision research. However, it does have many useful applications such as autonomous surveillance and human-robot interaction. And being able to achieve these tasks in real time could improve everyday life for the average citizen and contribute to the fourth industrial revolution. So many efforts have been made to reduce the complexity of existing algorithms for possible real-time applications. For example, dense sampling was replaced with random sampling, and the decrease in accuracy encountered was counteracted by increasing sampling density. There is also local trinary patterns which efficiently encode extracted features, and the very expensive task of optical flow calculation was replaced with motion vectors. And to boost performance, these motion vectors were enhanced with knowledge from convolutional neural networks. So the aim of this study is to explore this computational cost versus accuracy balance for action recognition by analyzing the bag of words framework. And as a result, we identify factors to consider when trying to develop and/or adjust existing algorithms for real-time action recognition of videos. And focus is placed on identifying the fundamental mechanisms that affect this balance. So what do we mean by cost versus accuracy? Well, we can state the paradigm as the more information extracted from input data, the higher the classification power of the algorithm, and thus the higher the computational cost. Thus, the balance between classification accuracy and computation necessitates an implementable and effective algorithm for action recognition. In terms of our methods and materials, we considered the very popular bag of words framework, which is flexible, simple, and offers a compact feature representation, and thus is computationally efficient. For training, the features extracted from training videos are clustered to form a vocabulary, whereby each cluster represents a visual word. And in the classification process, extracted features from test videos are compared to this vocabulary in order to encode the features and present it as a frequency histogram. And this histogram holds the count of occurrences of particular visual words. Thereafter, this histogram is pooled and normalized and fed to a classifier, such as a support vector machine for the activity classification. Even though the bag of words framework is computationally efficient, it lacks classification power. And as a result, many variants have been developed which aim to increase the accuracy by combining this framework with more complex algorithms, which in turn incorporate more information into the representation. And this agrees with our cost-first accuracy paradigm previously stated. So we analyzed how these bag of words variants went about to increase the accuracy, and from this 4 factors were identified to affect this balance, namely the saliency of extracted features, the sampling strategy, the optical flow algorithm, and the overall algorithm flexibility.